Finally, we are at the end of our topic of mechanics that looked at momentum and impulse. We are going to close off this chapter by doing question 2. We are told here that a block with mass 12 kg traveling at 20 meters per second to the west collides with a second block with mass 10 kg moving at 5 meters per second due west on a frictionless horizontal surface as shown in the diagram below. Now when we look at the before collision, we can see that the first object would be the 12 kilogram object, which is M1, because they said the second object here would be this one, the 10 kilogram object. And this means then that our initial velocity of the first object will be 20 and the initial velocity of the second object will be the 5 meters per second. Now I'll choose west as positive as well because I can see here that the direction comes with those velocities there. So this is to say that these two velocities are positive because they're going in the positive direction. You can choose this to be negative if you want to. I'm just avoiding to work with negative answers because personally I know for me that I tend to do errors when there's negatives in my equations. The other thing that we have to notice is that we have two objects here that are interacting with each other. This object will eventually collide with each other. As we can see that there's a collision in the statement. So that means here that we have what we call a system, because a system is defined as a collection of objects that interact with each other. And we don't only have a system, but we actually have a closed system or an isolated system, because they say to us that there is a frictionless surface, meaning this surface here, there is no friction, the friction is 0. And in lesson 6, we talked about this to say when the friction is ignored and also when there is no air resistance, our net external force will be 0 and making the system to be a closed system. So I can see that I'm dealing with a closed system. Now the question continues to further go on to say after the collision, the two blocks combine and stick together. So here after collision, these two blocks, they collide and combine here and they stick together, they become one thing. This is to say here that I'm going to have M1 plus M2 because I'm combining the mass of M1, which is this one, with the mass of M2, which is this one. Now I see them as one object now that has M1 plus M2. That means also they will move with the same velocity, meaning the velocity of the first object final will be equal to the velocity of the second object final. And I can call this velocity V final to say they have the same velocity. They move with the same velocity. Now, when I look at this problem, it is actually for me a problem that requires the knowledge of the conservation of linear momentum. And also maybe we can be asked by the types of collisions, elastic and inelastic collision. The reason I'm saying that is because I can see that there's a collision and this collision occurs on a system. I have two objects that interact with each other. And also my system is a closed system, and I know that when the system is closed, the momentum should be conserved. So for me, I think is a question that will require us to know that knowledge. This is to say that this is not a projectile motion. This is not Newton's second law in terms of MA. This is not electricity. It's very important to know, for you to be able to classify or to know what problem you're dealing with when you solve them. Now I'll go and answer my questions because I have a full understanding of my problem. The first question says to us here, explain why this collision is elastic, and they give us 2 marks. We can see here that when the 2 objects collide, they actually stick together, and this actually becomes a totally inelastic collision, because we defined a totally inelastic collision to be a type of collision where the objects collide and stick together. Because remember, when the objects collide and stick together, our total kinetic energy will not be the same. It won't be conserved. Some of it will be transferred out of the system as heat energy. Some of it will be sound energy. And there will also be a deformation, because for these objects here to combine, it means here they have to deform, they have to change shape and combine and be one thing. So there's a change in shape, what we call deformation. And when that happens, some of the energy will be transferred or converted to other forms of energy. It will leave the system and go to the surrounding. So that's why this actually collision is inelastic. So we are doing question 2 here, and we are on question 2.1. I would say here, when I answer this question, that there is deformation during the collision. Since the blocks stick together, therefore the total kinetic energy of the system is not conserved. If we compare the total kinetic energy here and here, we won't get the same value, because some of the energies I said will go out as sound, heat, maybe light if there's some sparks happening there. And therefore our total kinetic energy after collision would be smaller actually compared to before, because some of it here has left, it's been converted to other forms of energy. So that's how you would answer that question. We can go to question 2 but before we do that, maybe let's see, this thing is marked out of 2 marks. We are going to get a mark to say, to give a reason, to say that there is deformation in the system, and to conclude that our total kinetic energy is not the same, right? Because that's what defines an inelastic collision, to say the total kinetic energy is not constant, is not conserved. And you can just check spelling errors before you move to the second question to see if your answer makes sense. So the second question says to us that calculate the magnitude of the velocity of the combination after collision. So we are actually now looking at this velocity, the magnitude of the velocity, meaning the speed. What speed are they moving with? And in fact, I see already I've drawn a vector here. We expect that the velocity should go in this direction, because we can see that this object here has a big momentum. It will just combine and push the whole thing to that direction. Now, to do this, we are going to use our law of conservation of momentum, because we already learned that the momentum is conserved. So I'm going to have here m1 plus m2 times V final is equals to M1 V1 initial plus M2 V2 initial. Now, if you want to know how I got to this equation, please go check lesson 6 and the previous questions that we have done. Now, from here, I'm going to substitute my values to say I have the mass of 12 for the first object and I have a mass of 10 for the second object, and I'm looking for the final velocity of the combination. And here I'm going to have a 12 times the 20 as my mass and velocity. Then we're going to have a 10 times the 5. And from here, this question becomes really boring because it's an arithmetic question now. This would give me a 22. Perhaps this side I can just punch the whole thing with a calculator just to save time. I'll say 12 times 20 plus 10 times a 5. And this gives me a 290. Now, at this stage, I'll then say my final velocity would be equal to the 290 divided by 22. And this should give me 13.18 meters per second. Because here we want the magnitude of the velocity, it means I'm going to leave my answer without writing direction, because now this answer is telling me that my velocity is actually going to the west, which is what we expected, because we said this block will push that block and they will go to the west. But we don't want velocity, we want the magnitude of velocity. So I'm not going to write direction here. Very important to be able to distinguish between speed, which is the magnitude of the velocity, and the velocity when you write your answers. Now this question is 4 marks. So as usual, don't mark the formula. Correct substitution on the left hand side and correct substitution on the left hand side. And you'll get the mark for your final answer, which is the 13.8. And also this answer, you can look at it as a answer that is in the correct order of magnitude. I mean, we're having a 20, a 5. I do expect a number that can be between these two or slightly above these two. So the 13 makes sense to me. It's not an extremely big number or a small number for the numbers that I started with. Now I'll move to question 2.3, which then says to us, use calculation to prove that the collision is inelastic. Remember, in 1.1 we know that this collision is inelastic. So here they want us to prove by a calculation. As we have done in the previous question, to prove that the collision is elastic or inelastic, you have to compare your total initial kinetic energy to the total final kinetic energy. And in this case, because it's an inelastic collision, the two should not be equal. We actually expect that they should not be equal. So my total initial kinetic energy would be given by 1 over 2 m1 v1 initial squared plus 1 over 2 m2 v2 initial squared. And at this stage, this becomes a simple substitution problem where I'm going to have the 12, half 12, 20 squared plus 1 over 2, 10, and we have a 5 squared. Now this becomes something that we can use our calculator to solve at this stage. then I get an energy here of 2,525, and is measured in joules. We will do the same with the total final kinetic energy, which will be given by half m1 v1 final squared plus half m2 final squared. And again, before maybe I substitute here, I would like to perhaps rewrite this equation as v final squared m1 plus m2. Remember that the initial and the final velocity is the same velocity defined by v final. So that means we have a common factor here of v final squared. I'm going to take that out here as a v final squared because I'm going to be left with m1 times m2. If you want to learn this properly, go to the previous lesson and question. I've done a full step for this. Now here I'm going to substitute my 1 over 2, and we said our final velocity of the whole system now that we calculated is that 13.18. So I'm going to have here a 13.18 squared, then I'm multiplying this by a 12 plus a 10. Now I'll punch this in my calculator to have the 13.18 squared, and we have a 12 plus a 10. So this gives me an energy of 1,910.84, because we're going to round off the 6 there to be 84. Remember, we're rounding off to 2 decimal place, and this is measured in joules. We are going to then say that since the total kinetic energy initial is actually not equal, do you see that the two are not equal? This is not equal to that. I mean, we have a 2,000 here, we have a 1,000 here. Actually, the total kinetic energy is greater than the total initial kinetic energy is greater than the final total kinetic energy, right? They're not equal. Because of that, the collision must be inelastic. So this question is marked out of 6 marks. 1 mark for writing the correct formula, for writing the correct substitution for all these numbers here. If you made mistake of any of these numbers, you lose a mark. And 1 mark for the final answer. This will be marked also the same way. It will give you that 3 marks in that order. And that is where your 6 marks comes from. They are not really going to mark this statement in this question. It could be important for you to write the statement, but they're not going to mark it because already here we know that this collision is inelastic. We're just proving it. It's not like the previous question where they said determine if it is elastic or inelastic. We are done with mechanics, momentum and impulse chapter. What we'll be doing is that we'll be posting a series of exam question papers to have more practice on this topic.